Linear search explained. Let's say we have the list of numbers 10, 15, 23, 34, 41, 52, 65, 73, 80, 90. Now I want to find where the number 65 is hiding. At first glance, it's easy to spot, but what if you couldn't scan the whole list at once and could only check one number at a time? Well, the simplest way is to start from the very beginning and keep checking one by one until you either find 65 or reach the end of the list. That's what we call linear search, step by step. Here how it goes. First number 10, no. Next 15, still not. Then 23, not yet. 34, 41, no luck. 52, getting closer, but not 65. Finally 65, found it at the index 6. Simple, right? Just keep walking through the list until you find what you are looking for. How efficient is this? Linear search is straightforward, but it's not always fastest. It's the best case if the number is right at start, you are done in one step. In the worst case, if the number is at the very end or not there at all, you will have to check every single element. That's why we say linear search takes big O of n time. Basically, the bigger the list, the longer it takes. For a list of 10 numbers, at most 10 steps, but for a list of 1 million number, worst case 1 million steps. So why use it? You might be thinking, well, that sounds slow compared to other fancy algorithms. True, but linear search has its strength. It works even if the list is unsorted. For a small list, it's quick and easy. It doesn't care what kind of data you are searching, numbers, names, or anything else. Everyday examples. Scanning through your phone contacts one by one to find a friend's number. Checking a shopping list for whether you already wrote milk. Looking through a stack of papers to find the one with your notes. Let's also see it in code. In Java, we can write a method called linear search. It takes an array and a target number. Inside, we use a loop to check each element. If the element matches the target, we return its index. If nothing matches, we return -1. In the end, we create our array, set the target as 65, and call the linear search method. The output will be found 65 at index 6. Wrap up. So yeah, linear search isn't it the fastest in the world, but it's simple, it works anywhere, and it's often the first tool you reach for when dealing with small or unsorted data. It's like the walking of search algorithms, maybe not the fastest, but reliable and always gets you there.